Okay. Sorry for this one. My wife called and I didn't see the time, so I already answered this. I'm just gonna explain what happened. So, this will be for exercise number one. First, I listed all the numbers, the given numbers. In statistics, we call this one parameters. Okay. So when I say parameters, whenever I make a video about the statistics, you'll know that these are the given numbers. Okay. So we have here, this is your x, this is the given one. This is 250 grams. This is your mean. I call this one mu. In statistics, this symbol, this one here, wait, I'm just gonna change my pen. So this symbol here, this is mu, or sometimes they call it x bar or mean. Okay. In some they use this one x bar. Okay, but in others they use this one mu. This is a Greek letter here. Okay. They don't use this one much because it's hard to type in computer, so they usually use the x bar. So yeah, so this is your mean. So this is your mean here, 255 grams. This is your variance or sigma. Okay. No, this is your standard deviation. So variance is this one, and if you get the square root of the variance, that is your standard deviation. Okay, sigma. So this is your standard deviation in here. I hope your teacher already explained to you what is standard deviation. Okay, so the problem is that we want to find all the area of the normal distribution such that it should be under 250 grams. Okay, so our x, okay, would be all the numbers under 250 grams. So we have here our z-score formula. So we have z, okay, or z, I don't know how you pronounce it. So z, so x, which is your 250, that's the given in here, and then mu, which is your mean, divided by your standard deviation. So it's just plug and play. So everything, plug it here, subtract them together, then divide by 2.5, then you will get this one. Okay, 2.0. Now, okay, so in your normal distribution, so at the center would be your mean. Okay, this is your mean. This is your mean. Okay, and this would be your standard deviation. So this distance here is 1 unit of standard deviation. So another unit and another unit, and then this area here. Okay, this is what I'm shading in here. This is your area, and this is called the probability density. Okay, so it means this pink colored in here, this is 32 plus 32. That's why it is called the 68-98 rule. Okay, so this is equal to 68%. Okay, so the area of that from -1 up to +1, this area in here, which is 2 standard deviations, because this is 1 as well, that is 68%. So the area of that is 68%. Okay, and if you're going to extend it again, okay, let's say extend it again on this area. So basically 68% plus 13.5 plus 13.5, so that is, what is that? Okay, so 68 plus 27, yeah, okay, so that is 95%. So it means from here up to this one, that is 95%. Okay, and obviously if you're gonna add 2.5 and 2.5, okay, that will be around 5%. So around, actually it's not 100%, but 99.99%. okay, and then you're gonna add this part as well. Okay, so now what are the use of this? Why am I talking about this one? Okay, so because that we already found out that our z-score is this, okay, -2, so it should be here. And what our concern is that all the numbers, okay, underweight, so less than 250. So now that we know our starting point in here, which is -2, so everything that is below, okay, this area, okay, and that would be our answer. Okay, so you could just answer here 2.5%, 2.5%. Or, okay, we also have here the standard normal distribution. Okay, this one. I normally print this one in my class and hand it to them, and then you're just gonna find it. So our computed z is -2, okay, 0.0. Okay, so if your computed z is 2 point, let's say, okay, let's say 2.3, so you're going to go here. Let me just change the color here. So 2, right? And then 0.3, so here. So this one, and this will be your answer. So what does this mean? It means that, okay, there is how many percent is that? So 2.118%, or that is the area of your normal curve. Okay, but now what we computed is 2.0, right? So from here, so 2 and 2, the answer is, okay, 2.28%. Okay, so the exact answer should be 2.28%, or based on our graphics that we just made, okay, you could just take it 2.5. Okay, I would suggest, okay, in your test, if your teacher lets you use this table, the table that I showed to you, it is called z normal distribution. Okay, just Google it and then search it. Okay, I would rather use the 2.28 because that's the exact area, rather than 2.5, which is, this is just an estimate. Okay, estimate for easier, because if you want to predict something, it's easier to say, oh, okay, it's around 2.5%. Okay, and I don't know if you're gonna study about the confidence interval, okay, which is part of the statistics as well, or we could say 5% confidence interval, so this side and this side. So whatever, we're not gonna talk about that. So yeah, and then I'm just gonna cut this here because I'm not sure if this will be enough to send in Messenger. Oh no, I'm just gonna upload it in YouTube anyways, whatever. So yeah, let's continue. Okay, so exercise number 2. Okay, here are the parameters again. So I have the mean, mu, whatever you call it, so 3.1, and the standard deviation, which is 0.05. Okay, now our acceptance, okay, acceptance is at 99.7%. okay, so if we're going to go back here, okay, let me just go down here instead. So the 99.7% should be, okay, in here, okay, all of this, okay, there you go. So we stop at, okay, 3 and then -3, right? Okay, that is your 99.7%. So that's why I have here, okay, +3 and then -3. So this one in here. Okay, so how do we find the lower and the upper limit? Okay, it's very easy. So you just have to get mu, which is our mean, which is 3.1, which is in here. So 3.1 minus, okay, 3, which is from here. This is our lower part. So our lower part is this one. Okay, and then times our standard deviation. So our standard deviation is 0.05, and then we got here 3.08. So that's our lower limit. And for the upper limit, so instead of subtracting, we're going to add. We have 3.1 plus this one in here, and then you got this one. Okay, so I'm gonna explain this one first. So our mu, okay, our mu, this one, okay, should be at the center. Our mean should be at the center, and the mu that is given in here is 3.1. So 3.1 in here, And then I said this is one standard deviation, right? So if this is 0.005, okay, so this part should be, if we're going to add that, that will become 3.1, 0, and 5, right? And then if you're going to add another one, so this is 0.005 again, add in here, so the next part would be 3.110. And if you're going to add another standard deviation again, the third one should be 3.115. Okay, so the difference between this is just 0.5, 005. Again, the difference is just 0.005. So you get the idea, right? Okay, so now we have here, this is your upper limit, which is 3.115, which is what we got in here. Okay, you see, 3.115. And then if you're gonna do that also in here, so instead of adding, you're gonna subtract as it's going on this side. Okay, so subtract, another subtract, and another subtract. So instead, it will become 3.085. So that's your lower limit and upper limit. Okay, there will be a case as well. Okay, using this formula, using this formula in here. Okay, so sometimes the z score is given and you have to find the standard deviation, so you just have to manipulate the formula, right? I hope, yeah, it's basic algebra on how to manipulate things, especially if your mu is missing, your standard deviation is missing, or your x is missing. Okay, so make sure that you know how to manipulate things. Okay, so yeah, that's it. That's pretty much yeah, exercise 1 and exercise 2 that you gave me.